As I had a pass. Oh, Jacqueline. Oh, that's awesome. Yeah. As I believe I kind of summarized or looked ahead with you on Friday, where this is all leading is just solving a polynomial equation, or rather finding all of the zeros of a polynomial. So if you even look at example 1, it says find all of the zeros of f of x, and it gives you the polynomial f of x. That's where, even thinking back to 5.5, when we started factoring polynomials, we were using factoring as a method to solve polynomial equations, which would be finding the zeros. And then 5.6, we're kind of now tying in all of our factoring techniques with what we did in 5.6 with using the synthetic division to get a remainder of 0. We're tying that in again to find the zeros. So it's all leading to just me giving you a polynomial and saying, find all of the zeros of this polynomial. So we're going to go through example 1. I will say, while step 2 of this 3-step process, while step 2, like I said, is what example 2 from Friday's notes was asking you to do. So there are questions that will just ask you to do what step 2 is asking for. As part of this whole process, steps 1 and 2 are really optional. They are helpful steps, but with this type of problem, as long as you're giving me what all of the zeros are, that's what I'm looking for. Steps 1 and 2 are really there to help you determine what to even do for step 3, but if you didn't have the work shown for these as part of this problem, you wouldn't lose points, say, on the test. So, this is what I recommend doing when you have a problem like this, is before you even start, know at the beginning how many answers you should have. So step 1 is just to determine the total number of zeros. So by looking at this polynomial, how many zeros should we have in the end? How many answers should we have? 4. Why should we have 4? It's the highest exponent. 4 is the degree. So whatever the degree is, that's how many solutions or zeros you should have. And I'm going to add to this, when you're finding all of the zeros, you are really, another way to ask this same question would be if I told you to solve this equation, x to the 4th minus 18x squared plus 12x plus 80 equals 0. So when you're finding a 0, you're really solving the equation of that polynomial equal to 0. So that's another way to think of it. Okay, so we know we should have 4 answers. That's just helpful to know from the beginning. So here is what we did not get to on Friday, with me leaving time for you for the homework quiz. Determine the type of zeros and examine the number of sign changes for f of x and f of negative x. So from Friday, I just want to show you what these directions would say. You don't have to pull out Friday's note sheet, because it's very similar to what, or it's the same process as to what this example says. So these examples would say, state the possible number of positive real zeros, negative real zeros, and imaginary zeros of the polynomial. So you're not finding the zeros, you're finding the possible number of positive real, negative real, and imaginary zeros. And I will explain when we get to step 3 how that can be helpful here. So we're going to find the possible number of positive real zeros first. And what I'm actually going to do, you don't have to do this. I just want to do this so I can move my sheet up here. I'm going to rewrite the function right here just so I don't have to keep moving it back and forth. So our function f of x is x to the 4th minus 18x squared plus 12x plus 80. Okay, so to find the possible number of positive real zeros, and again, on that note sheet, this is using Descartes' rule of signs. That's what it's called. You don't have to know the name of it. You just have to know how to use it. The possible number of positive real zeros is the number of sign changes that you see in the original function. So when you look from one term to the next, the number of times that it would change from positive to negative or negative to positive. So when I look at f of x, and you want your terms to be in order, you don't have to fill in the zeros, but you want your terms to be in order. So I'm starting with a positive x to the fourth, and then my next term is negative x squared. So that is a sign change. I went from a positive term to a negative term. And then from the second to the third term, I have a negative 18x squared to a positive 12x. That is another sign change. I went from a negative to a positive. And then I have a positive 12x to a positive 80. They're both positive. It's not a sign change. So I have two sign changes. So I could possibly have two positive real zeros, or I could have, and I'll write this and then explain why, or I could have none at all. So the number of sign changes is the most, or the highest possible number of positive real zeros I could have. That number then could also be less than this by 2. It says in the rule less than this by an even number. So I could have 2, or I could have 2 less than that, which would be 0. Now, why this information is helpful is when I'm doing step 3 and I'm actually looking for the zeros, I know that if I find one positive real number that works, there has to be a second one. Because I said I'm either going to have 2 or I'm not going to have any. So if I find one that works, there has to be a second one. That's where this process is going to be helpful moving forward. So that's how you find the possible number of positive. Then I'm going to find the possible number of negative real zeros. And these are found by finding the number of sign changes for f of negative x. And I'm going to show you how to find this. So for f of negative x, this means in the original polynomial, you're replacing all of the x's with negative x. Now I'm going to show you a shorthand way to find this versus having to write all of that out. So what I want to show you, I'm just going to write it off to the side. Really, this would be, I'm going to focus on the negative part of this, the -1 that's in front of the x. If I say raise -1 to the second power, what is that equal to? +1. So when you raise a negative number to an even exponent, the outcome is positive, which means anywhere I have an even exponent, if I replace, say, x to the fourth with negative x, it's not going to change. It's still going to be positive x to the fourth because a negative to an even power stays the same. If I raise -1 to the third power, what is that equal to? -1. So when your exponent is odd, your outcome is negative, or rather the sign is going to change. So in f of x, wherever I have an odd exponent, the sign of that term, so I'm focusing specifically on the 12x, because that's the only odd exponent I have, that's going to change to a -12x. Okay, so again, if your exponent is even in this new function I'm writing, the term stays exactly the same. Nothing changes. If the exponent is odd, the sign in front will change because a negative to an odd power is a negative. It changes the sign. So f of negative x is going to equal, again, x to the fourth. It's an even exponent. It stays positive x to the fourth minus 18x squared, positive exponent, so it stays minus 18x squared, plus 12x is an odd exponent, so it'll change to -12x. And your constant, there's no x with it, it's always just going to stay what it is, so I have plus 80. Okay, so that's how you find f of negative x. Even exponents, the terms stay exactly the same. Odd exponents, the signs of the coefficients will change. Okay, but then to find the possible number of negative real zeros, you now find the sign changes of this polynomial. So where the terms change from positive to negative or vice versa. So from the first term to the second, I went from a positive to a negative. That's a sign change. From the second to the third, they're both negative, so no sign change. From the third to the fourth, negative to a positive, that is a sign change. So I have two sign changes. So my possible number of negative real zeros will be 2 or 2 less than that, so or 0. So again, step 3, when I'm looking for zeros, if I find one negative number that works, I know a second one has to work. Because I either have 2 of them or I don't have any at all. Okay, so this is just finding the possible number you could have. We still have to find the possible number of imaginary. And for this, you don't have to do it this way, but for this, I typically set up a 3-column chart. So in my chart, I'm going to have my positive real zeros first, and for the possible positive zeros, I said we had 2 or we had 0. I'm going to have the possible negative zeros in the middle, 2 or 0, and then the possible imaginary in the last column. Okay, and here, how you're using this chart, I'm going to ignore the last column completely until the end. What I want to do is come up with the different combinations I could have between the positives and the negatives. So what I mean by that is I have 2 options for each, 2 or 0. So I could have 2 positive real zeros with 2 negative real zeros. So I could have 2 and 2. Or I could have 2 positive real zeros with no negative real zeros. Because my options for negative were 2 or 0. So those are all of my options if I have 2 positive. I could, though, also have 0 positive. So I could have 0 positive real zeros with 2 negative, or 0 positive with 0 negative. So overall, because I have 2 options for each, I have 4 different combinations. And now, how to figure out the possible number of imaginary zeros is you want to go across each row, and we know in total there should be 4 zeros. So if I add these together, like 2 positive and 2 negative, that's already 4. I would have no imaginary zeros. But in the second row, if I have 2 positive and 0 negative, that's only 2. That means the other 2 would have to be imaginary. So I need 4 answers total. Each row has to add to 4 in this case. So then if I have 0 positive and 2 negative, again, that's only 2. The other 2 have to be imaginary. And if I have 0 positive and 0 negative, that's 0. That means all 4 would have to be imaginary. So these are the possible number of imaginary zeros we could have. We could have 4, we could have 2, or we could have none at all. Okay, so this is what example 2 from Friday was asking you to find, just the possible number of each. And I'm going to reference that as we do part 3. So this step for this problem is technically optional. It's a helpful step, but when I'm asking you just to find the zeros, if you didn't show me this, you're not losing points. If I just asked you for this, you would need to do it. Okay, so practice on just this would be the back side of the worksheet from Friday if you wanted practice on only this step. Okay, questions there? Okay, so now to step 3, actually finding the zeros. We should get 4 answers. So this is really where your answer to this specific question comes in. So in summary, this is what you're going to do. List some possible values and then use synthetic substitution, which remember this is just synthetic division, to evaluate f of x for real values of x. So how we're going to start out is make a table. And I'm actually going to include, again, so I don't have to keep moving my sheet, so you don't have to do this. I'm just going to write what our function is, again, so I can move my sheet up and not keep looking back and forth. That way, if I move it up, I just have the function right there. Okay, so you may want a calculator for this part. Here, you are just going to substitute in different values of x until you find a y value of 0. Okay, now I'm going to show you the method I use to start, and this is really where doing step 2 can be helpful, because say, it isn't true for this example, but say if I did step 2, I got that there should be no positive real zeros. That would mean when I'm doing step 3, there's no point in me plugging in positive numbers because none of them will work. So that's where step 2 can be most helpful, is it eliminates what you should try. In this case, though, we could have positive real zeros, we could have negative real zeros, so we can try both. So I typically start, even if I see it's not going to work, I typically start my table with the x value 0. Okay, so if I plug 0 into this function, what will I get? 80. All right, obviously 80 is not 0. I'm way far from 0. And now because it is possible that I could have positive real zeros, I usually start with positive numbers. So I'm going to plug in 1. And remember, I showed you this before. I know it doesn't work on all calculators. It can be helpful if you put your x value in parentheses, and then you can just keep replacing it with the other x values you plug in, and you don't have to retype the whole thing every time. So I would put in parentheses 1 to the 4th power minus 18 in parentheses 1 to the 2nd plus 12 in parentheses times 1 plus 80. If I plug in 1, I get 75. Okay, so my y value is still not 0. It's still far from 0, but compared to where it was, it is closer to 0. So I'm going to keep going. I'm going to plug in 2. So now I can just go up and replace all of my 1s with 2s. And that y value is 48. Okay, again, still not 0, but it is closer. So now I'm going to plug in 3. That y value is 35. Still not 0, but closer. Plug in 4. Okay, when I plug in 4, I get 96. Okay, that is now going the opposite direction I want it to go. I'm now farther away from 0. So here is where I would reevaluate. It's possible that 2 positive numbers are going to work or none are going to work. So because my y value started going the opposite direction of where I want, they're now farther from 0, I'm now going to try negative numbers. I'm going to switch gears and start plugging negative numbers in. So kind of use your best judgment as to what you should try. So now I'm going to plug in negative 1 to the 4th power minus 18 times negative 1 squared plus 12 times negative 1 plus 80. And that's 51. And then if I try negative 2, I found an answer. When I plug in -2, I do get 0. So when I list my 4 answers, -2 is one of them. Okay, now here is what you want to do when you find a 0. Is you are now going to use synthetic division with the value you found, which in this case is -2 as your R value. So with R equals -2. Okay, so I'm going to have -2 in the box. And then I'm going to list the coefficients of my polynomial. Remember, if you're missing terms, you do have to fill zeros in. So for my coefficients, I have 1 for x to the 4th. I don't have an x cubed, so I need to fill a 0 in. I have -18 for x squared, +12 for x, and then +80 for the constant. And I need to bring down the first coefficient of 1 and then do the synthetic division process. So 1 times -2 is -2. Plus 0 is -2. -2 times -2 is +4. Plus -18 is -14. -14 times -2 is +28. 28 plus 12 is 40. 40 times -2 is -80. Plus 80 is 0, and 0 is the remainder. Now, when you do this, you should get 0 as a remainder because the function value is 0. So that's using that remainder theorem that we covered. This is thinking back to 5-6. If you did this, you plugged in a number, got 0 in the table, and then you did the synthetic division and did not get 0 as a remainder, something in your synthetic division isn't right. And it could be that you didn't fill in zeros. So just make sure if when you're doing this, that should come out to be 0 for the remainder. Lisa? That would be, if -2 is a 0, that means you're really dividing, the factor would be x plus 2. So -2 is the R value. You're thinking if I told you to divide by x plus 2, you would switch it for R. When you actually have the value here, you don't have to switch it. That is your R value. And that would be the case if you did switch it to positive. It wouldn't work. You wouldn't get a remainder of 0. So that would be a hint something didn't go right with your division. But this number is R. That's a good question, when to switch it, when to not switch it. Okay, so now from here, so we're not done. We only have one of our answers. But why we did this is we're now trying to use this to break down our polynomial into a new polynomial, which is the quotient, and work with the quotient to find our remaining answers. So now my quotient is going to be 1x to the 1 power less than x to the 4th, so 1x cubed, minus 2x squared, minus 14x plus 40. So now we are trying to solve this equation if this was equal to 0. Okay, so here's where, again, you have to kind of use your judgment and think of techniques you have. I can certainly continue with the process I was just doing, and you might have to. Whether or not it works, just looking at this equation, if I ask you to solve this, does anything stick out to you that you could try to solve that for x? GCF. Yep, thinking of factoring, you could see if there's a GCF. What? Okay. Okay, but grouping is what you would try, right? So when you have 4 terms, grouping with this one is not going to work. But if you want to make a note to yourself, when you end up with 4 terms, you could check to see if factoring by grouping would work. Check factor by grouping. Because if it does work, that's going to be probably the fastest way to get to your answers. Okay, now for this one, and I try to choose examples that aren't like the easiest example and then you have the hardest ones to figure out on your own. I try to choose ones that are more challenging. So for this one, it doesn't work. So we can't actually factor by grouping, but that is something you could check or be thinking of. So if there's no other factoring method you can use to solve this, you have to do this process again, but with this polynomial. So now I'm going to make a new table, and I'm looking for more zeros or another 0, but with this polynomial and not the original. You could still use the original. If something is 0 in this polynomial, it'll be 0 in this one. But I would use the new one. Now, again, where step 2 is going to help, we found one of our answers is -2. That is a negative real 0. Since we have 1, we know there has to be a second negative real 0 that works. So I should continue with negative numbers. So I'm going to continue where I left off and plug in -3, but I'm going to plug it into my new one, my new polynomial here. So I have -3 cubed minus 2 times -3 squared minus 14 times -3 plus 40. That's 37. Okay, that doesn't work. Try -4. -4, the y value is 0. Okay, so I found my second negative real 0. It's -4. Again, -4, when I'm going to do the synthetic division again, that is the r value. But now when you do the synthetic division, use the new polynomial, the quotient, not the original. Because again, we're trying to break this down into something we can factor to get all of our solutions or solve a different way. So now my r value is -4. My coefficients are 1, -2, -14, and 40. Bring down the 1, do the synthetic division. So 1 times -4 is -4, plus -2 is -6. -6 times -4 is 24, plus -14 is 10. 10 times -4 is -40, plus 40 is 0, and your remainder should be 0. But now, what's nice about this quotient is it's 1 power less than x cubed, so now it's x squared minus 6x plus 10, and I can set that equal to 0, so now I'm trying to solve this. Once you get it to a quadratic, again, you can keep doing this process, but you don't have to because you have multiple techniques that you can solve a quadratic equation with. So what's one way we can solve a quadratic equation? What was that? We could try the diamond, see if it factors. So if I set up a diamond, I'd be multiplying to 10 and adding to -6. Are there two numbers that work? I hear some no's. Okay, so if it doesn't factor, again, if it does, sometimes it will. I picked this example on purpose. It doesn't factor. That doesn't mean you can't solve it. You just have to use a different method. How else could you solve this? Quadratic formula. Don't have to have it memorized, but you need to know how to use it and when to use it. I have it up here on the board. So by the quadratic formula, my solutions will be x equals the opposite of b. B is negative 6, so positive 6, plus or minus the square root of b squared, so negative 6 squared is positive 36, minus 4 times a is 1, times c is 10, all over 2 times a, which is 1. And then just simplify or evaluate this. So we have 6 plus or minus. Inside of the square root, we get 36 minus 40, and that's negative 4. So the square root of negative 4, all over 2 times 1 is 2. So 6 plus or minus, how would you write the square root of negative 4? 2i. Square root of 4 is 2, but it's negative, so it's imaginary. So we need the I, and that's all over 2. And then since 6 and 2 on the top can both be divided by the bottom 2, we can divide all 3 of those numbers by 2. So this is really 3 plus or minus 1i, or just I. And those are your other 2 zeros, 3 plus I and 3 minus I. Okay, now for your answer, I know I have all of the zeros circled. Thinking ahead to the test, if I can't tell what your answers are, you're not going to get all of the points. I need to see, these are my answers. I don't want to search 5 different places to find it. So I want you then to regroup and just list your answers. So the zeros are negative 2, negative 4, and then you can list these together as 3 plus or minus I, or you can list them separate as 3 plus I and 3 minus I. It's up to you how you want to list those two. But in the beginning, we said we should have 4 answers, and we do. 2 negative answers that are real, and then 2 imaginary. And if you look at the combinations we came up with in step 2, having 0 positive, 2 negative, and 2 imaginary was one of the options we had. That just so happened to be what the form of our answers were. Okay, so to gather from this, you're finding all of the zeros using a combination of techniques that you know. The higher the degree is, obviously the more work it takes to get your answers. So if your polynomial is a 3rd degree, it's going to be less work than this. If it's a 2nd degree, it's less work than this. So I picked a 4th degree to go through more of a process than you will always have to go through. Questions? Okay. I have one last example that is working backwards from what we just did, but hopefully as we go through it, you can think back to chapter 4. You've done problems similar to this already. So from up here, some key information that you need to understand. So it says in chapter 4, you learned the product of complex conjugates. So complex conjugates would be A plus bi and A minus bi. So when one is a sum and one is a difference, so they're not total opposites, it's just that middle operation is either a plus or a minus. It's just switch. So the product, if you multiply complex conjugates, it's always a real number. And then complex conjugates or complex roots always come in conjugate pairs. So you can think about the example we just did. 3 plus I and 3 minus I were 2 solutions. They are conjugates of each other. Imaginary solutions always occur in conjugate pairs. So it does give another example. So it gives a polynomial, and it says if one of the roots is 4 plus 6i, the other one would be 4 minus 6i. So they would occur in a pair. So this applies to all polynomial functions. If an imaginary solution is a 0, then the conjugate of that imaginary number is also a 0. And that's what's explained here. If It says in the second sentence, if a plus b times I is a 0, then a minus b times I is also a 0. Okay, so how would you use this information? Why do you need to know? If you look at example 2, this is what problems are going to say. It says, write a polynomial function of least degree with integral coefficients having zeros that include -1 and 1 plus 2i. Okay, so I'm going to take out that information. We are given that the zeros are -1 and 1 plus 2i. Here's where you need to determine, or you need to know, that if 1 plus 2i, since it's imaginary, if this is a solution or a 0, then its conjugate, which is not listed, is also a 0. So 1 minus 2i is also a 0. And you would need to fill that in. It's not given, but you would need to fill it in. So these are, I'm just going to say these are conjugates. So that you would need to fill in on your own. So there are really 3 zeros. You cannot have an odd number of imaginary zeros. They always occur in pairs, so you have to have an even number. Okay, so now we are taking the zeros and writing the function. So it is the reverse of what we just did. We had the function, we found the zeros, we're working backwards. So how to do this is, I'm just going to put f of x equals, because we're writing the function. It's very similar to when you were given the roots of a quadratic equation and I asked you to write the equation. You take the zeros and you first write it in factored form. So I'm going to review this with you too. This was the factor theorem. It said if x equals c is a 0, then x minus c is a factor. We had talked about that. I know it was something we just talked about, but I had highlighted that with you, I think on Friday, when it gave the zeros and then the factors. So in the factored form, the value, your 0 is always the opposite sign. So if -1 is a 0, then as a factor, it is x plus 1. Okay, now for the imaginary solutions, this is how I would suggest you write it. 1 plus 2i is your whole value. So it's x minus 1 plus 2i, and I'm going to put the 1 plus 2i in parentheses, because it's minus that whole thing. And then I also have x minus 1 minus 2i. So write it in factored form first. And then you multiply these to get your equation. So how to multiply these? You're only going to multiply 2 at a time. If you have imaginary solutions and imaginary factors, multiply those together first. Because your final equation should not have I in it. When you multiply these factors together, all of the i's should cancel out. And you'll see how. So pay attention to what I'm going to explain. I'm going to rearrange this a little bit. That, in my opinion, it makes the multiplication easier, but you have to see why it works. In the parentheses, what I'm going to do is notice the 1 plus 2i and 1 minus 2i are grouped together. I'm going to regroup it so that in the first one, the x minus 1 is grouped together, and the same in the second one. The x minus 1 is grouped together. So this is going to become x minus 1 plus 2i, and then x minus 1 minus 2i. So I just regrouped it, and I'm going to explain why I did that. Notice now, because I regrouped it, these are now conjugates. Because I have the x minus 1s are the same, that's like our a, and then I have plus 2i and minus 2i. These are conjugates. That means when I multiply these using FOIL, I would multiply the first terms together, which are both x minus 1. So that would be x minus 1 times itself, and I'm going to have to FOIL that in a minute. But then when I multiply the outer terms, x minus 1 times negative 2i, and then the middle terms, x minus 1 times positive 2i, those cancel out. When you multiply conjugates, the middle terms always cancel out. So you could write that down, they'll cancel, or just leave it. And then when I multiply the last terms, positive 2i times negative 2i is minus 4i squared. And now when I simplify this, I do need to FOIL the x minus 1s. So that would be x times x is x squared. And then my two middle terms I'm going to combine right away. X times negative 1 is negative 1x. I'm going to have another negative 1x, so negative 2x. And then negative 1 times negative 1 is positive 1. But then when I simplify minus 4i squared, what is I squared equal to? Negative 1. So minus 4i squared is really negative 4 times negative 1, so it's positive 4. And notice my i's are gone. And that should happen. It should always happen. So now I'm just going to combine the 1 and the 4, so x squared minus 2x plus 5. Okay, so that's what I get when I multiply the two imaginary factors. I still need now to multiply this by x plus 1, but the i's are gone. So now when I multiply these, you've done this multiplication before. I just need to make sure I multiply the x to everything and the 1 to everything. So if I multiply x times x squared, that's x cubed. X times negative 2x is minus 2x squared. X times 5 is plus 5x. And then distribute the 1. 1 times x squared is plus x squared. 1 times negative 2x is minus 2x. 1 times 5 is plus 5. And then combine like terms, and you'll have your function. So I have x cubed. I can combine minus 2x squared and x squared. That's minus x squared. Positive 5x minus 2x is plus 3x, and then plus 5. And that's your function. Now again, based on these imaginary solutions, this was a more challenging example. Not all of them are exactly like that, but hopefully then you get the idea. So before you go, we just have a minute. You need to make sure you get the assignment for the practice for this. It is a lot. So you need to practice it. Questions. We're doing more of this tomorrow, but if you have questions.